Thanks very much, SOSV. And thank you all for joining us. We're really happy to be here. I'm very pleased to be joined by Leah Ellis from Sublime Systems and Sandeep Najaman from Electra. We're going to be talking about electrifying heavy industry today, and these two startups are some of the leaders in doing that. So I'd like to have you both start with just giving us a sense, the 30-second explainer of how your technology works. So Sandeep, I'll start with you.
Thanks, Julia. Just excited to be here. So Electra's mission is to develop clean, pure iron resourcefully and responsibly to help build the future from ground. And why clean iron? That is because, steel is 98% iron, and 90% of its emissions come from making of iron first in order to make steel. What we have developed is a process that's an electrified platform, as you mentioned, and it takes electrons, actually green electrons that are renewable in nature, and converts the variety of ores we can find already mined in the mines to commercially available ores, and then we convert that into pure metallic iron while minimizing the waste across the entire value chain. In simple terms, if I was to put it in, we take ores, we put them into solution instead of melting them in a blast furnace. And that solution is purified, and we remove impurities that are coming through the ores as co-products. And that zapped solution within electrons and extract iron out as a pure metal.
That's fascinating. Very different from how we make iron and steel today, but extremely important if we're going to decarbonize. And Leah, Sublime is focused on cement. Can you run us through how your process works?
Yeah, if may help to start by talking about how cement is made today. So cement is currently 8% of global CO2 emissions. We use more concrete than almost any other material in the world. So it's made in these big rotary kilns. So taking limestone, which is a calcium carbonate, it's about 50% by weight CO2, cooking it to extraordinarily hot temperatures, about the temperature of hot lava, 1400 degrees Celsius, which is very fossil intensive. So all in all, 1 ton of today's Portland cement results in 1 ton of CO2 emissions, half from the fossil fuel, half from the breakdown of these carbonate minerals. Now, Sublime is rethinking the cement making process in a way that keeps the final stoichiometric composition of hardened concrete the same, so same strength, same durability, but we're rethinking how it's made and from what materials it's made. So we take calcium silicate minerals, almost any calcium-bearing mineral, running it through a process which works at ambient temperature using electrochemistry to break down rocks instead of using heat to break them down. So the product that we make is a 1-to-1 replacement for Portland cement in terms of all the properties. Its stoichiometry is the same, which is the ratio of the minerals which react together once you add water, but the crystal structure is different because it's never been inside a kiln and heated to these temperatures. So that's how our process works and how it avoids the CO2 emissions. So I like to differentiate our technology from post-combustion carbon capture and some others by describing it as true zero instead of net zero, because there's no addition and subtraction, there's no carbon capture. Which means that ultimately, once we get to the same scale as, these 1 million ton per year Portland cement kilns, we'll be able to have similar cost because there's no added cost, no added complexity of dealing with, that 1 ton of CO2 emissions for every ton of cement making.
Amazing. From hot lava to ambient temperatures, that certainly seems better for the planet. Now, steel and cement are enormous industries, and there are huge companies who are also trying to decarbonize. Steel in particular has been doing a lot of work. There's about 100 million tons of green steel capacity that's been announced. How do you both differentiate your technologies from the hydrogen or the carbon capture that they'll be using? Leah, you gave us the first part of that, true zero, not net zero. Sandeep, maybe you can talk a little bit about how you will differentiate your material from that made by the big incumbents.
Yeah, if you think about differentiator, at the end of the day, in a commodity material, you first have to start with cost. And we believe we have the lowest cost to achieve steel making by producing the iron through our process. And this can be broken down into two parts. One is that if you look at the total cost of producing, let's say, iron to get to steel, 70% of that comes from two factors. What is the cost of energy to make this happen? And what is the cost of iron ore that you need to convert into iron? And on both the fronts, we have a very strong economic lever that we are bending towards in our favor. On the case of energy cost, being also a low temperature process, like what Leah described, that we're not doing molten metal at 1600 degrees C. Our plant is operating at sub 100 degrees Celsius and nominally around 600 degrees Celsius on certain parts of the plant. We are able to follow the availability of electron and thus seek intermittent power versus base green load. And that reduces the cost of the electron by almost 3x. And on the ore side, we have very high degree of flexibility, not to use the commercial ores, but also be able to use ores that are currently not being used. So they are really low value in the ecosystem or in the value chain. And hence that reduces the cost of that lever as well. The second one is value we produce. At the end of the day, all irons are not created equal. We have a 99.9% electrolytic grade iron, and DRI, which is another competitive way to get there. Best case scenario, if you want to do economically, is about 88% metallic content. Pig iron is about 94% metallic content. So having more iron and less impurities creates value for the steel maker. We also create value by refining all the impurities into co-products that increase, again, value for the overall ecosystem, like alumina, which is a tram impurity that blast furnaces or DR-grade pellets cannot use, and we can extract them and we can refine that as pure alumina and feed into aluminum making as a byproduct. And last but not least, it is actually, in the area of steel making, we are the most modular approach to get there. That helps with scaling. That helps with making the economical viable unit that can be demonstrated much smaller and massively increase the learning rate that you need to reduce cost.
Fascinating. So cost, purity, and modularity being the places where you really see
value.
And
value as well.
Leah, is that similar for you? Is that how you're thinking about competing with the big cement producers?
Yeah, well, I would say we don't intend to compete with cement producers. Cement producers today are, it's all about logistics and operations of trying to get massive amounts of material to the concrete companies. So it's all about moving, with barges and rail and terminals and harbors and trucks. So we see them as our execution partners, and they're just as committed to carbon reduction as we are. And we see ourselves as the technology provider and the technology partner, where the two of us work together to have this swift and massive impact in CO2 emissions. So the way I like to think of really the climate problem broadly is like, I use like the leaky tap analogy of, imagine a spigot that's broken and there's just, CO2 spilling out everywhere. It's sort of like a crisis situation where you need an all of the above approach. And the first thing you do when you have a leaky tap is put a bucket under and collect it right at point source. And so I see that as being the post-combustion carbon capture. It's a necessary temporary solution that you do in order to fix the tap and to get to that true zero permanent fix, which may take longer, which may require expertise and new parts to be ordered and for those things to happen. And so there are things that the industry is doing and can do, both to capture CO2 and then also to make sure there's less effluent coming out of that pipe. So the industry is moving very quickly with supplementary cementitious materials. So there are cementitious materials that can be blended with Portland cement that have lower carbon reduction, but you'd have to start sacrificing performance at a certain point once you blend too deeply. And so those things are happening right now, and that's great. We really need everything. And so what I see Sublime coming and doing is being that solution for the ultimate way that we will make cement in the coming millennia for a post-carbon world. So we do think it's an all of the above approach. And of course, it all comes down to cost, and that's actually very difficult for cement because, some people ask, like, your cement, like, sure, it's green and maybe it costs the same, but like, how is it better? How can you make better cement? And truthfully, there is no such thing as better cement. People won't pay a penny more for better cement. They just want the same cement, right? But there is one thing that people care about in cement, especially on the concrete side, which is the reliability. And that's reliability in terms of logistics. So having the materials show up in time and the quantities and the quality that you want. And that is a place where Sublime can have an advantage, because today you make cement by taking a carbonate rock, which contains impurities, baking it, in which case it loses half its weight to CO2. All of those impurities get concentrated, and it picks up impurities from the bituminous coal that you're burning to get to that high temperature, and from the tires and plastics that you're burning in these kilns to reduce the amount of fuel you're using. So the quality of cement actually varies quite widely. And because the construction industry is rightfully conservative, you take the standard deviation of how much that cement quality is varying, and you add a multiple of that in terms of over design to make sure that you're appropriately covering your butt. And this is something everyone does. It's mandated. So by making cement that is pure, because I don't know if you've seen pictures of Sublime cement in the field, it's much lighter in color because our process is inherently purifying. We're taking a mixed mineral, separating it into its constituent minerals, and blending it into a cement. So it's inherently purifying. The quality of the output doesn't necessarily depend on the quality of the input. So we're hoping we can prove, once we're at scale, that our cement is more reliable, that you can use less of it because it's more consistent, and that its performance, day to day, week to week, plant by plant, is the same. And so I think that's what better cement means. It's not really in terms of properties. The properties are necessary but not sufficient. It's about making sure your customer can rest easy and get along with business as usual with the least amount of cost.
Absolutely. That has actually brought us on to the customer side of things, which is something that I wanted to touch on. You made the point that a customer, wants the thing that they have always bought before, but I think they are now becoming a little bit more discerning and also wanting it green. Sandeep, have you found that this can be a barrier when you're talking to the people you want to buy your steel? Are they saying, well, how do I know it will operate in the same way? How do I certify it? How have you been demonstrating that it will work just as well?
A number of ways. First of all, I think one of the key distinctions versus, let's say, cement is that, we produce RN. And this RN is a product that is used today to make steel. So we are substituting, we are a substitute to RN. And then what's also unique in the steel industry is when it's supposed to go in an electric arc furnace, is that we melt this RN along with scrap to make the new steel. So in fact, the RN that is coming with anything that we are bringing in is already washed out, is already reset, and we reset the entire crystal structure to give the reliability the steel actually needs to produce. So the risk of us from a certification perspective is actually, first of all, low, because we are substituting that is already existing, and then we are going through a process in which the memory of where this RN came from has already been sort of washed out. Having said that, we do see that there are a lot of new segments that the blast furnaces needs to be taken out of, and electric arc furnaces needs to come in. Example would be like a car body. The top surface of a car body is a part that's typically made in a blast furnace today, because that's more pure way to make steel. And EAFs have to sort of get there by seeking more pure iron from us, hopefully, to produce that. So that product qualification cycle obviously has to be redone for, let's say, automotive company. And as a result, the path we are on is to build a demonstration plant that we can produce that amounts of iron that is needed, that we can give to the steel maker, that can make that coil that can be stamped out to the part, so that the end demand user, let's say in this case could be an automotive car company, can qualify also that part and qualify along with us that yes, that the purity of the iron actually help them get to that part.
Amazing. So the iron going into the steel making process, you will see at the end that the part is exactly as it was intended. Leah, when you were talking about the over designing that often happens in the building sector, how you have to add more and more cement and concrete to make sure that you're at the performance standards you need, do you think that is an important part of the value that you're bringing, the fact that your cement is very pure and you can use less? And do you think that value will actually be realized when there are these standards that people have been doing for so long? Do you think that's a big hurdle to overcome?
Yeah, I think there's immense value in making sure that your cement is very consistent. There's this whole admixture business to tune the properties of the cement. So I do think that's very big, and that there is this question of risk and making sure that you don't. It's funny. Like in Silicon Valley, people say like the tagline is "Move fast, break things." And that's not something that you can do in construction. So our product roadmap, we call it Sidewalk to Skyscrapers. And we're working with Don Davies, who is longtime president of Magnuson Clemensic, a big structural engineering firm, to get a protocol for how you test things in incrementally challenging applications so that you can work with the industry and never push them beyond their comfort limit, and that you're listening every step of the way and getting their feedback and using them as part of your team to develop your product. Because truthfully, the cement industry is so massive that even if you can only do basements, sidewalks, mud mats, like footings, that is still a massive total addressable market. We can use all our cement in that. It is our goal and our ambition. We have a very clear path to being that full drop-in replacement for Portland cement everywhere that Portland cement is used, but there's no point in rushing it. And so, you don't want to ram things down people's throats, especially as a startup coming into a very big industry where, you really have to respect how things have been done, how people want things to be, and you have to make that a reality to them and really listen. And so that's what we're doing, and it's honestly really, really fun.
That's great to hear. And the process that you outlined, where you start with a sidewalk and you end up in a skyscraper, that brings me to the question of scale. So I'd love to know the scale that you're both at right now. How much material can you produce, and how does that compare to a typical plant in your industries? So Sandeep, can you tell us where you're at right now?
Yeah, so we are at a pilot scale. So we're already in existence. So we have a pilot plant that is producing iron. The nominal capacity of that plant is 100 ton per annum. And next year, our goal is to build a larger demonstration plant to scaling this technology, as well as producing iron that as I said before, could be used for qualification purposes. And that obviously is much larger scale, largely because, in a steel mill is so large that an EAF melt is a 200 ton melt, which is, think about putting 200 cars together and melting in 1 hour. I mean, that's how the magnitude of that melt process is, just to give you an idea. And we could be putting in easily 30, 40 tons of iron coming from Electra into that. We need to obviously expand capacity for qualification purposes. At the end of the day, a large-scale steel plant is about 2.5 million tons in capacity. So then we have a roadmap to get to a first commercial plant. And this is where modularity, which I mentioned earlier, is so critical, that you can step into the size and as well as prove the scale up, as well as cost, as well as economics, product qualification, all of that in a stepwise manner and to get there as quickly as possible.
And Leah, you have a partnership with Holcim. Is that something that's going to help you accelerate your scaling plans?
Yeah, we have partnerships with both Holcim and CRH, so two of the largest cement producers in Europe and in North America. And they're absolutely helping us. Going back to that part of, we know what we do well, which is technology. We know what they do well, which is logistics and operations, things that are not to be underestimated. And frankly, don't make my team get out of bed. Like, we're nerds, right? So we bring the tech, you bring the muscle of getting this to market, of distributing it to hundreds of ready mix plants and making that into quality concrete. It's these types of partnerships that allow swift and massive, instead of like going it alone, which, we would never go anywhere if we were going it alone. It's just far too capital intensive. And frankly, all this land and resources is locked up. Like, good luck as a startup raising VC money to like buy a barge, right? Or a terminal in the Boston Harbor. So that's going to be really important to us. So going back to your other question about scale, we've moved from lab scale to 250 tons per year in the past 4 years, even during COVID. So the first step was going from grams to kilograms continuously, and then from that R&D continuous to pilot plant continuous. And we did 2 scale-ups. First, 100 tons a year, and then we wanted experience scaling it again to 250 tons a year. And each time you're matching the quality of the material that you're producing in R&D, because how you operate the process really affects the quality of the cement. And so now we're gearing up to do our next big leap to 20 to 30,000 tons per year capacity. So this plant is called our industrial demonstration plant. It is a module, and you're saying this as well. The modularity is so important, because to get to massive scale, you can do it 2 ways. You can do it by making it bigger, and there are cost efficiencies by simply making things bigger, like pinch and zoom bigger. But there's also cost efficiencies, especially, and speed efficiencies from making copy paste units. And the cost down you get from doing that may actually be similar to the cost down effect from simply making it larger. So defining your module, running that at very large scale, getting all of the economic quality data, that allows you to get closer to being project financeable, because you've reduced risk. You have no more technical risk, no more scale-up risk. It's all very well understood, and you simply replicate. So that is the point we hope to get to with this demonstration scale plant. Recently was announced an $87 million grant from the US DOE to do a significant cost share of that project. So that is currently what we're focused on, is taking all of this process scale-up knowledge and now moving it to an orders of magnitude scale larger. And then also working with Holcim and CRH to find sites where we can build these 1 million ton per year plants, at which point we can get the volume up to drive down the cost. And as you know, like siting, permitting, all these things take many years. And so we're starting now to make sure that once Holyoke, this demonstration plant, is complete, we can hit play and start engineering these bigger scale plants, all in the spirit of swift and massive.
That's incredible. I think you are both beating the stereotype of hard tech taking an extremely long time to develop. You've both moved very quickly through these phases. I have one final question about scaling, and then I want to move on to talk about financing in the last 5 minutes that we have. But my question, and maybe I'll give it to you, Sandeep, is these industries are huge. They have large assets. How do you see the transition between processes? Do you think you have to wait until all of these plants naturally retire? Do you think there will be disruption? What does that look like?
Yeah, so I think that's a very good question, because we have to be cognizant that this is a $1.5 billion industry with massive asset base, and somewhat similar to how coal-fired plant power generation was and had been thought through as well. So the way I'm thinking through that piece is that, look, if you look at the blast furnaces that are in China, that is the youngest fleet of blast furnaces that are in the world today, like 14 years. So that's going to take obviously longest time to transition. But the rest part of the world, especially in Europe, North America, other parts of the developed world, or where the world capacity or the capacity has not yet been put, they are massively moving towards where we need to go, which is to recycle more steel, hence EAF steel making. And that's where we see, even at the scale of moving the shift that is going to happen and leaving even China aside for a moment, there is hundreds and hundreds of millions of tons of iron that needs to be fed into these electric arc furnaces, largely because the scrap that we have available, the reservoir for scrap that we have available, especially the high grade, top grade scrap that produces the highest quality steel, that resource is limited and it's not going to increase because that proportionally increases by GDP, how many cars you make, so how many parts you stamp, and whatever is left out of the stamped part is the highest quality scrap you get. So that reservoir is not increasing. So we're seeing this shift happen in the industry at the macro level that, yes, while depending on the age of your blast furnace, you will make an economic choice how to transition into a solution set that gets you to full zero emissions, like what we have here as well. But the size of the market presents such a huge opportunity that it's not a constraint from where we sit today from a demand perspective, and is a massively supply side constraint that we are seeing.
Great. So filling a gap that scrap can't fill on its own. Amazing. Yeah. I want to talk a little bit about financing first-of-a-kind projects. This is a huge challenge. It's getting talked about a lot more in the climate conversation. Leah, you mentioned that you've had an investment from the DOE. Do you think there has to be some kind of government money involved in these first-of-a-kind industrial projects?
Well, has to. I mean, like, we'll find a way to do this by hook or by crook. But I guess the question is, what role does government have to play in clean tech, and should it play? And I think we all know that the cost of doing nothing is, much more expensive than the cost of participating. So there is a social cost to this, and we see this with the hurricanes in Florida, with the potential collapse of the Atlantic current, which I've been doom scrolling about a lot recently, and how that could affect temperatures in Europe and how that could leave a lot of hot water at the equator, intensifying these storms, etc. So we have to preserve business as usual. And there may be a cost to that, but it is far less expensive to preserve business as usual now than to adapt to a very uncertain environment where insurance premiums may go up, where things might no longer be insurable at all, where the cost of doing business goes up, So, I think that government does, capitalism and, public companies, they make very good short-term decisions. Like the invisible hand of capitalism will optimize and regulate itself in the short term to, make the best quarter by quarter decisions. It is government's role to provide like longer term, constraints so that we can keep doing business as usual for as long as possible. Because having a safe and prosperous society that is just very normal and safe benefits us all. And so there's a moment of opportunity now that you can invest to get these technologies demoed so that they can move to first full scale, so that the premium can be low, so that companies can start buying low carbon cement to qualify that, to lock up the supply and keep, future proof their supply chain. And so that hopefully we won't have to, put all of our money into adaptation and resilience. So there's a moment here where the ounce of prevention or, the megatons of avoidance are worth the gigatons of cure in the future. So I do think government has a role and a responsibility, especially in the domain of cement, where the U.S. government buys 50% of the cement that is used in the U.S. through Federal Highway Administration, DOT. Like, government provides infrastructure. So their demand signal here and their willingness to be part of the solution is going to be really important, particularly for the cement sector.
Absolutely. Definitely a vested interest there. Sandeep, I'm going to give you the last word in the last minute that we have. Do you think there's enough access to capital, and where is it going to come from?
I think so. I think there is absolutely, while it is challenging, as you think about being a startup that's not bankable, how are you going to raise the capital? But raising the capital, there is a method to this madness. And if I was to break that problem down, comes through, look, you have to right size the plant, even though we have volume and demand signals that is coming. What is a minimum viable plan that you need to go build to show economic viability to get industry relevant size that you can then grow from there? So you have to start from there as well. It's not like if you were to build, they will come. The answer is yes, they will come. But you also have to bring the investors with the capital to help you build that. The second part of that equation is that, if you were to look at inputs and outputs and you were to minimize the risk that is to the investor and matching the tenor of inputs and output and guaranteeing an operating margin that no matter what way the market goes, you have a minimum economic viability of the project, people are willing to put the money on that. But it's our responsibility to show and do this in a project where they are not taking the risk itself. And there are ways to do that. Pricing mechanism, what's your tenor of your financing that is matched to inputs and offtakes agreement, and pricing hedges that you can have both on inputs and outputs that guarantee almost that you are economically viable. And last but not the least, you do have to build a capital stack, and how are you financing it? If your project has an IRR of 10%, the answer is that there is only one pocket of capital that gets you there. Either is that the government or is the sovereigns that clear their hurdle rate, obviously, or is perhaps a strategic that desperately wants that product and say, I will deploy my capital to get there. And there are first movers that are willing to do that. You can improve your IRR by getting non-dilutive funding. For me, that's the role of the government that can play in it. That could be cash grants, could be credits, whatever those things that are available. But the bottom line is what I'm saying is if you build the right strategy here, which is starting from day number one, that you have to pass this chasm of scaling and you are not bankable and you put all the pieces into place, I believe with strong value proposition, there is enough capital on the table that is going to come and help you move this thing through.
That's great. That's a really positive note to end on. Thank you both so much for being here with me. I am feeling a little bit more helpful. Hopefully a vacation from doom scrolling for me tonight, if not you, Leah. Thanks so much, both.
Thank you.
Thanks so much.